Hey, everybody, and welcome to another episode of React Roundup. This week on our panel, we have Lukasz Heisz.
Hello, everybody.
Justin Bennett.
Howdy, folks.
I'm Charles Max Wood from devchat.tv. And this week, we have a special guest, and that's Chris Toomey.
Hey, everyone.
Now, do you want to tell everybody who you are and why you're famous?
Sure. Famous is a strong word, but I work at a development and design consultancy called Thoughtbot, which historically we've been very popular in the Ruby on Rails world, but over the past many years, we've spread out into all of the technologies that are necessary to build digital products. So that includes a lot of React and other front-end technologies. I personally am a development director here in our Boston studio, so I'm leading a team of developers and helping them to work with our clients, build the products that they need. And I also, in my very some spare time that we do find, I host our Bike Shed podcast.
Ah, gotcha. Cool. Yeah, I remember when they started Bike Shed. And I remember when DHH was talking about the color of the bike shed. And anyway.
Yeah. Comes up a lot. Turns out the answer is yellow. We solved that one. But it is a great name. And actually, I mean, it's just we have a symbol. It's there. It's a yellow bike shed. But it does evoke the right ideas, I think, of developers talking about things and getting into nuanced specifics and all that fun. So I certainly really enjoy that, and have been very happy to take over the hosting mantle middle of last year. So
nice. Are they still doing giant robots?
We are doing giant robots as well. That one has gone through a couple of iterations. That's our longest running podcast. And that was originally hosted by Ben Orenstein, and it was more entrepreneurial focused. And then actually I came on as a co-host for a 6-month period when Ben and I were working together on some of the products that Thoughtbot was building, online learning platform called Upcase and a few other things. And then Ben has actually left the company at this point, probably a year and a half, maybe 2 years ago. And so Chad Pytel, our CEO, has taken back over the reins, and it's back to being focused more on entrepreneurial interview type structure, but talking about the work of building digital products and building companies and being an entrepreneur and all those sort of ideas. And then the Bike Shed then is the contrast to that, focusing specifically on development things. And we also have Tentative, which is our design focused podcast. So we sort of cover all of the different facets of the work that we do here in podcast form. Nice.
I have to say I really like Chad. And I know we're talking about Thoughtbot and podcasts and stuff like that. Interestingly enough, for people, if you were following Giant Robots when Ben was the host, you can also hear him now on The Art of Product, I think is the name of the show that he does.
Yep.
So anyway, I wind up talking to Ben like every year at MicroConf. And so, yeah, last year we had the conversation, or maybe it was the year before, I don't remember. But he was either leaving or had just left Thoughtbot. So, And we've had lots of Thoughtbot folks on Ruby Rogues and JavaScript Jabber and a few other shows. So, yeah, long history there. But anyway, let's move over and talk a little bit about GraphQL and React. And it's interesting because people are going, oh, another GraphQL show. But this is kind of an interesting angle, and I really want to dive in and get some context around it, because you talked about how GraphQL informs the building of client-side apps. And, you know, I said this before the show, but I'm going to say it again because I think it's relevant to the conversation. And that is that most people get in, they start building an app, they start kind of getting an architecture in place, and then they go, oh, we need data. And so then they pull GraphQL in, and I'm wondering, you know, because you said that your talk was mostly focused around building more of the architecture around GraphQL and what it gives you. So how is that different? Like, where does that come from? And what does a GraphQL-centric app look like instead of a React-centric app?
Sure. Well, I would say that when we're building React applications that leverage GraphQL, we're definitely still building React applications, and it doesn't fundamentally change the React aspect of things, but it does inform the data flow, how props are handled, things like that. Specifically, the talk that I gave at Boston React Conference, I dug into the pattern of building out applications and allowing data to be co-located with components. So a lot of times we'll look at GraphQL and we'll say, this is great, I can ask for all the data that I need, but we'll think about that in terms of a top level, say, screen component. So this screen or page owns everything underneath it. And that ends up, especially in a GraphQL context, being a ton of data and a lot of responsibility for that parent component to have in order to ask for all the right things and pass that down through the tree. So alternately, the approach that I explored in the talk was one of using a feature of GraphQL known as fragments, which are basically subqueries. or not subqueries, but they're portions of queries. So you can say, whenever I ask for a user, I want these fields from a user. And we can use those to actually decompose a GraphQL query in the same way that we can decompose React components by breaking out smaller components. And then nicely, we can actually take those fragments and co-locate them with the component that needs that data. And so by doing that and then composing up both the React components and the associated GraphQL fragments, we can end up with a single query, which is great for performance and great for consistency. But we can also allow each of those subcomponents to own their data and to express that pretty directly. That's sort of the core idea. And I can pause there and see if we want to dig into any of aspects of that, because that was a bunch of stuff that I just shared out there. So
yeah. So I see that in the you're using, like your example, you're using the Apollo client, right? Mm-hmm. And the Apollo client is, if we like naively using the Apollo client out of the box, we always think about like a single query. Mm-hmm. But I remember, and this part, like I'm not an expert because I didn't actually use it. I just like saw the talks of like Relay, which was like an early client, right? And I remember Relay having this concept of pieces of the queries being owned by the components. So is this like the same pattern that Relay uses, but you are like actually even like in a simpler way composing it because it's only like string composition in the in the end? Like, is it informed by Relay, inspired, or?
Justin, do you want to?
I can speak to this.
Sure.
So Artsy uses Relay pretty heavily. So we're actually like pretty prolific contributors in that community. So yeah, it's the same sort of pattern. So in Relay, like the common sort of setup that you'll see is you will have, like for a component, you'll have a kind of your visual component that just like takes in props, right? Like your regular React component. But the component that you actually export from the file that's consumed by the things is what Relay calls a fragment container. Mm-hmm. So that defines kind of the data needs from the query for that one component. So it's this exact thing that Chris is talking about. So you're just defining the fragment. So like at Artsy, we might have like an artist, but we might have like an artist info component. So we would have an artist info fragment container that defines a GraphQL fragment for the subset of information from the artist query that this one component might need. So it's really nice in that when you move this component to other places, it's like data fetching requirements comes with it. So you don't have to think about, oh, I need to change what props I pass down to this, or, oh, did I pass the right props to this thing? Or do I have to check or update or all this stuff? So, and what Relay kind of does behind the hood is it like analyzes all your like component structure and like aggregates everything up and compiles it into one like one static query at build time, and then you can ship all that off to to server. So
I think based on that summary, I haven't actually explored Relay as much, but I've spent most of the time that I've worked with GraphQL on the Apollo side. It sounds like they're very similar, although it sounds like Relay has a little more built-in support for this functionality, which certainly makes sense because GraphQL came out of Facebook, Relay came out of Facebook, and fragments are a core part of the GraphQL specification. So it makes sense that they've actually even leaned in a little bit further. And that was sort of the reason for my exploration was I wasn't seeing folks talking about this as much on the Apollo side. And I don't mean Apollo, the company, they have good documentation and everything around this, but I wasn't seeing the pattern used or leaned into as much on the Apollo side. So I wanted to sort of explore that. And I've said this to a number of people about the talk, but it was the most fun I've ever had preparing a conference talk because I was basically just playing with the app and teasing things apart and trying to refactor things and see if I could clean it up. And I'd look at something and be like, I don't feel like that data need belongs here. I don't think this file actually cares about that, and see if I could pull that apart. And at each step of the process, I was very happy to find that, yes, I can largely deconstruct these sort of things. And the same, the parallels between React and GraphQL are really interesting to me. And the same sort of decomposition that we see of components works pretty much directly with fragments. There are a couple of caveats and a couple of subtleties, but in general, this works extremely well. Although in the Apollo world, you're working with strings, essentially. So that's not entirely true. Like when you're defining a query, you're defining typically a template tag literal. And ESLint, we can set up an ESLint rule that will validate that, make sure everything works. Similarly, if we're defining a fragment, it will also be one of these template tag literals. passed to the GQL function typically. And we can do the same sort of validation there because a fragment is actually a formal part of the GraphQL language and specification. So we can make sure that you're only asking for fields on the user that the user type actually supports. The only subtlety is as you compose those back up into the parent query, at that point you are just inlining strings. So if at any point any part of your application tries to like actually run that component, if you have any tests touching it, then you'll be fine. But there is that like one layer of validation that I would love to see a little bit more of a compiler, essentially, which it sounds like Relay actually has that built in. So that's the one thing that I'm a little bit jealous of from standing on the Apollo side of things. But overall, the experience is fantastic in the way that it allows each component to sort of stand on its own and say everything that it needs, from data to presentation to to all of the other things that we get in the little bits of behavior. We get all of that, which is fantastic.
Yeah, so the Relay compiler does take care of kind of all of that for you. So, at build time of your app, it will actually prepare all the queries and do, the sort of validation to make sure that, the fragments are valid and all that stuff. And there's also, so we use a package called Relay Compiler Language TypeScript, which emits TypeScript definitions for the actual GraphQL queries and fragments and everything. So by the nature of just using a fragment container, the props that get passed into your visual kind of component are automatically typed. So it's nice from that perspective. So it automatically it basically compiles the query. So the same thing that the GraphQL like tag, template literal tag kind of does was like compiling it. So the compiler will go ahead and analyze the query, compile it, validate it, and then generate types for it and everything, and does all that at build time. So it's pretty sweet.
There's a similar functionality on the Apollo side. There's a code gen tool that they've shared that will walk down the directory tree and actually look at any of those template tag literals and generate the associated types. And then, as you were saying, it can work as well for fragments, which that's actually the part that I almost like the most, because if you build this one big type at the top of your tree, because you only have one query, you end up with this very large, complicated data type. But as you break it down into these smaller and smaller pieces and say, one of the examples that I have in the talk is a language thing, which is like on GitHub, we have languages like Ruby or JavaScript, and they have a name and they have a color. And the color is an interesting bit that is only available through the GraphQL API. Actually, it's not available in the REST API. But that little bit of data, knowing those are the two pieces of data that this component will have access to. And also there's that added fun of, it turns out the color is actually nullable. It's possible to have a language that's new enough to GitHub. They're like, I don't know, this is a language, but we haven't really heard of it, so we didn't give it a color yet. And therefore the color will be null. And so the types are present in the GraphQL layer. And then when you do the TypeScript generation, you get that type to flow through and say, this is a nullable value, so you should provide a fallback or handle it, or at least be cognizant of the fact that you may not have a value here, which undefined is not a function is a thing that we run into in the JavaScript world sometimes. So any advanced warning I can get from that is wonderful.
So this is probably like tying the problem back to the first Charles' question. So if you have all these tools at your disposal, like if you have all the discovery tools that are, you also talk about like graphical, I don't know how to pronounce that.
Graphical, yep.
Yes, graphical tool that you can explore your types in a typed manner too, like with autocomplete and stuff. And if you can generate the types for your JavaScript code or TypeScript code to help you. So do you think that start from the GraphQL layer is a good start when you're about to create a new application? Because it will like inform your front-end code.
It's an interesting question. When I think of GraphQL, I think of it more, the word that comes to mind is platform more than application. So if you're building an application and you need to have an API for that, I would still reach for GraphQL because I'm sufficiently convinced that it is that much stronger of an option than REST. And there are very few reasons that I would consider not that, other than particular external integrations where that external integration requires a REST API. But basically, otherwise, I'm looking to GraphQL. But I think GraphQL really shines when, rather than building an API for specific pages, you are building a general API for your platform. I think GraphQL really shines in the world of platforms where we don't just have a single application. We have a mobile app, and maybe we actually have iOS and Android, and especially where we might have multiple different facets to the data. So for instance, Lucas, you work for ZocDoc. So that's a pretty classic two-sided marketplace where we have healthcare providers on one side, and we have people trying to find healthcare. And then maybe there's even a third facet of administrative folks that are trying to help coordinate interactions, and if there are cancellations, supporting that and sending out emails and things like that. So you have a core domain model with true things that you can say about the data, but you have different views essentially into that data that you really want. And I think GraphQL is incredibly, as good as it is as a default option, it really shines in those cases where you can start to build an API that defines the domain of your platform. And then each new view that you need to build, or each new even little application, is that much easier to do because you can leverage all of the power that's been built into the type system of GraphQL. Ideally, you can spin things up much quicker. So it's, it would be really great if we had an admin application for approving or rejecting new doctors that are coming onto the platform. That's very easy to do in a GraphQL world and increasingly difficult in a REST world, when especially leaning towards mobile clients. So that is sort of the view that I take of it. But I think to maybe answer your first question, I basically lean for GraphQL as my first choice whenever I'm given the choice.
So my follow-up question to that is then, how far down the road? So let's say I'm building a new application. I don't really know what kind of data, or if I'm really going to be heavily using data from the back end. Maybe I'm using some other front-end service or something like that. And I start thinking, okay, I've got to start thinking about the data. So I start evaluating my options, and it could be REST, it could be Firebase, it could be any number of different things. At what point do you have to make that decision to start getting the benefits of having chosen GraphQL and get some of the shortcuts and decisions that you're talking about with building this into your app? Because once you get past a certain point, it seems like now you have to go and fit GraphQL back into everything else you did.
Yeah, it's definitely a decision that, like with any large technical or architectural level decision, changing it down the road is going to be difficult. Mm-hmm. But that said, my view on GraphQL is it has more of a characteristic of investment than other things that I've seen. Mm-hmm. Typically, when we're building out REST APIs, we're building out endpoints often somewhat specific to use cases. To this page, this dashboard needs a bunch of data, so we're going to build a new endpoint just for it. Nothing else is really going to be able to benefit from that, or probably shouldn't, due to the specific nature of it. With GraphQL, because you're building this type system, because you're defining the graph of data and how things in your domain work, each additional type that you add, each additional field that you make available, each additional root query entry point can benefit all of the applications that are part of the platform. I was actually surprised when I started building out GraphQL servers for the first time, because I came at it from a client-side perspective initially. And I was very pleased to see that it was not much harder than building a REST API. In fact, in a lot of ways, I enjoy it much more. But I also found that the benefits compound over time as you add new things, and each new piece is it fits that much better in part of a whole, because you are building a whole thing. You're building a new layer into your application, whereas a REST API tends to be, we're providing the data for these specific uses, or we're serializing resources. And serializing to JSON is not a problem that I want to spend that much time on, despite the fact that I've spent a lot of my career spending time serializing things to JSON.
Yeah. This REST versus GraphQL debate is an interesting one, because I worked a lot with REST. Like in B2W, an e-commerce platform I worked, like we had in our checkout application, we had to deal with at least 12 different endpoints to do work. Mm-hmm. So there's never a case where one endpoint solves your problem. Mm-hmm. This is crazy. You need at least 3-4 requests to do almost anything. So I think that the debate is it's not that it's better or worse. It seems to be that REST is more low level. Mm-hmm. It seems that maybe there's a case for REST and stuff, but my GraphQL server will consume the REST APIs or something, if you still want to have them. But consuming them from the client seems to put like so much logic responsibility in the client that it just seems like I'm using like a tool that is like too low level for that.
Yep.
It's not a matter of like being better or worse. It just seems like it's a different level of abstraction.
That definitely rings true to me. And I think I gave 2 different variants of the same talk. So one was at Boston React conference, talking about GraphQL and sort of introducing that idea and showing what it looks like inside of a React application. I also gave a similar version of the talk at GraphQL Summit, but with that, I tried to explore a little bit more of how GraphQL affects the architecture of an application. And I think that was sort of coming back to the first question that Charles had asked. What you're describing there of when working with a typical REST API, often the client needs to do a lot more manipulation. It needs to have more knowledge about the structure of the platform. It needs to know, what are all the API endpoints that I can hit? How do I stitch together the data from different endpoints such that I can display everything? And basically, no page on any internet-enabled application at this point is just showing one thing, like one resource. And so our clients end up having to own that complexity. And what I've loved in exploring GraphQL, and particularly GraphQL coupled with React and leaning into this fragment pattern, is just how simple things can be. It's getting back to like, my React components are just focused on their very simple jobs of expressing their data needs in this case, and then deciding how to show that to the world, deciding how to present an interface to that data. And even to the point of changing data, GraphQL has a wonderful feature in, they're called mutations when you want to change data within GraphQL. And a mutation has or can have an associated subquery that after the mutation runs, the query then is evaluated and you get that data back. So rather than posting to a REST endpoint, you get back whatever they give you. You're able to express, again, your data needs. And you can say, I know that by changing this thing, this other aspect of the system is going to change. If the example I use in the talk that I gave is when I'm starring a repo on GitHub, that is going to change the total star count. And so I'm able to fire the create the star repo mutation and then ask back for the total star count after the fact. And Apollo or Relay will take care of caching that data, updating all of the things in React. So my component essentially has to do nothing. It's basically just wiring up these little pieces, but it doesn't need to think about, after I change this, what I have to go chase down. And that speaks to me of sort of the dream of React from day one, which is React's job is just to take some data, some props and some state, and to render it to the UI. And that's it. We want to keep that as simple as possible. And with GraphQL applications, I feel like we're really delivering on that promise. And that's part of what excites me so much is, as we want to build out multiple different front-end applications, any complexity that we can pull back or share and have consolidated and ideally in this one centralized server, I think the better. So,
it's interesting the way you're talking about this, because a lot of times the architectural decision is, how do I weave this into what I'm doing? And instead what you're talking about is, these are all the things I don't have to do when I'm using GraphQL.
Yep.
And, it's kind of a powerful thing. I mean, the thing that gets me excited about a lot of these technologies is, I'm a results guy. I want to see the outcome, right? If I can get the job done in less time, and it's easier to think about, that's a major win for me, because the result is basically what I said. I get more done, I get what I want, and it's simpler. It all kind of ties back together, but because you're not concerned about, what's at this REST endpoint and has it changed and what are we thinking about there, you can focus on the architecture of your system and making sure that your components just have one job to do.
Yep. And I think actually digging into that even a little bit deeper, one of the other themes that I see within GraphQL is the idea that from its very inception, as far as I understand it, GraphQL was very much centered on the needs of the client, unapologetically so. So its job was to make it easier to build and modify over time front-end display of data. Not exclusively front-end in terms of React, but it largely was built in that context. So that is the ideal use case. But in general, its goal is to be very close to the end user. What are the needs that the UI is going to have to present this data? And I think that's a good bias to have. I often end up being the person that's implementing both sides of the API. So I'm both writing either the REST endpoints or the GraphQL, and then I'm writing the client-side code to consume that. And I am perfectly fine with a little bit of extra work on the side of the server implementation, especially because that's going to be shared across all clients, such that our client applications can evolve more quickly as we learn things about how people use the application. We're like, you know what, they're not using this, but they do seem to care about this. Could we integrate this other related piece of data? In a REST context, that may mean hitting a new endpoint or adding data to an endpoint that didn't necessarily want it in the first place. With GraphQL, the answer is generally, yeah, sure, go for it. We can change that. We can update it. We can show more data. We can show less data. We can fetch it after the fact. We can do a lot of... The GraphQL query language is a very good and expressive language that maps so well to the needs of the front end that I really enjoy that aspect of it as well. The fact that it's very much client-centric.
Yeah. One thing I believe it's a clear win too is the discoverability. In the REST world, we are like so dependent on the documentation that the teams generate for them, like the swaggers and comments and the Confluence pages that are outdated. Yeah, all these wikis, all this Confluence, like it's so hard to keep them like right fresh. Sometimes we say that Confluence is the place where ideas go to die. Right. It's
sorry for laughing, but I've been there, right? It's
we all know that feeling.
Yeah.
And the documentation is done, so and so then things move, and well, the documentation says this. Yeah, well, the code says something completely different.
Yeah, it's so difficult. Like it's already difficult to maintain like documentation in your code, right? Like which is like co-located. Like it's already like you need some discipline. Like maintaining documentation, like when it's like completely far, it's even more difficult. So no matter how much documentation that was like in front of me, I would like talk to the people. Yeah, let's talk to the cart REST API people. Okay, if I send an ID and blah blah blah, what like how is it? Okay, okay. So I would live in like curl. I would be curling like everything. Okay, all right. So this is the name. Oh, it's approved name. It's not name. Fine. So I feel that in this sense, like the discoverability of GraphQL, like it made the fact that there is a schema and stuff, it makes so much easier to just like understand what is available, what is not available, and like build your queries in your fragments inside that tool. So this is also like a huge win in my opinion.
So my personal view is the most important like starting point to any sort of application is data modeling. It's like figure out what your data requirements are. Why are you building this? What do users care about? And I think GraphQL does a great job of like making that conversation easier, because I can take the schema definition language for GraphQL and I mean, it's really human readable and we can like write that out. I can show that to a product manager. I can show that to any like person on the team, regardless of what their experience level is. And it's fairly evident what this sort of data is. And we can have a conversation around that and then put that into code. And that be the really source of truth for what the API exposes. So it's really that, I mean, there's been a notion in the industry for a while of like building something to a contract, and this like bakes that notion in. It is built to a contract. So you have like a guarantee that your API has these things available and they're this type. And that is such a really powerful thing to enable teams to collaborate effectively on building products.
I remember this story every time, like about mutations and in the REST world. So it was all about the posts and puts, right? I remember there was a case we introduced it like in the cart page of an e-commerce, the buy later feature, right? So if you click buy later, you remove your item from the cart and you add to the buy later list that will be there like next time you come back. That would be like a mutation in GraphQL. In REST, it's like one delete request to the cart to delete that particular item. And then I would need to add to create, like I would need to post a request to the buy later to create a buy later if it's not created yet, buy later list that it's empty. So now I need to put a item in this buy later resource. And this is like, I don't know, like in someone's like phone. So obviously a bunch of things would happen like while all these requests were going back and forth in the wilderness. So, and this is the kind of thing, like there was no one endpoint that would solve my problem. It's like, no, buy later must not know anything about cart and vice versa. And I was like, so that means that you can't help me.
Yeah, the idea of using mutation there definitely works and has like the possibility then of transactional consistency, which is really nice. If you're taking something from one list and moving it to another, you really want to make sure you don't, like, the first request doesn't succeed to remove it and then the second one fails to re-add it and suddenly you've lost data in the system. That's the worst case in my mind, the loss of data. But there's even another layer of GraphQL that we could lean on here. If those were two distinctly different operations, you can actually send up multiple mutations in sequence, and GraphQL guarantees that they will be run in order. So even if there weren't a use case specific mutation for that, if you're like, you know what, I need to do these two things back to back, I care that they're back to back, I want to send them in one conceptual request from the client, but they are exposed as two different things, GraphQL actually embraces that as well. Really, it feels like GraphQL was this fantastic, what if we were to rethink everything? Or reevaluate a lot of things that have actually historically existed. Because GraphQL is definitely built on a lot of ideas of SOAP and RPC and schemas and Swagger and all sorts of, there's a lot of prior art to basically every piece of GraphQL, but I think they did a fantastic job of bringing it together and making a cohesive whole out of it.
It's funny the way you're talking about this, because I interviewed Lead Byron for my JavaScript story. Monday. And a lot of what you're talking about is kind of along the lines of what he was talking about there. So
I've listened to a lot of the things that he and the other creators, Nick Schrock is one of the others, and trying to remember who the third person is. I feel bad, but there were three folks that were involved, and they've all spoken a bit about the creation and sort of the story of where GraphQL came from. And I really like that it has such an organic story of creation. It wasn't created academically at a distance from real world needs. It was created 100% from the needs of Facebook and particularly the newsfeed team. And then they built something that's immensely useful. It's actually even more interesting to me to see that they've now set it free. There's actually the GraphQL Foundation, and GraphQL is no longer, as far as I understand it, a Facebook project, but it has its own open source organization, maintainership, all of those sort of things. And so in contrast to React, which is still very much within the Facebook sphere, they've sort of given GraphQL out to the world, which is kind and sort of confusing to me as a person in the world looking at Facebook and it's wanting to own things, but here we are.
Yep. Yeah. This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code DevChat at Sentry.io to get 2 months free on Sentry's small plan. That's code DevChat at Sentry.io.
There's one other aspect of this story that I find interesting, which is for a long time, React applications were moving in an arc towards Flux or some implementation of that, particularly Redux really dug in and took a hold of the world. And for the first time, when I started to poke around with GraphQL-based React applications, I considered not using Redux. It had sort of become table stakes as far as I could tell, but then with Apollo version 2, initially with Apollo 1, they had built it on top of Redux. And then with Apollo version 2, they actually removed Redux out of the fold. And so I sort of leaned into that. I thought, all right, let's explore this. Let's see if we can get by without Redux. And it turns out for the vast majority of use cases, I found that, yes, you absolutely can. And you remove so much boilerplate and indirection from your code by doing that and just leaning on the power that Apollo and GraphQL give you. And the React applications that I'm able to build with that are so focused and simple. Granted, I don't think there's never a use case for Redux. I think it's still a fantastic library that if you're building very complex front-end heavy, say like a Google Docs editor, something like that, I would still want to have that stack of actions and the ability to undo and redo, and ideally also be backed by GraphQL, but have that be a sort of secondary concern and let Redux own the show. But the fact that I don't need Redux now as the way to own state, especially now with hooks, like that was the last, I think, piece that I needed to feel completely comfortable saying, ideally, I'm going to build applications with GraphQL and Apollo and a little bit of hooks where I need some local state or a tiny little reducer or things like that. Now it's just, these are the pieces that I need, and I feel great building applications with that.
Have you been using the local state for Apollo?
The default implementation for most Apollo setups is an in-memory cache. So we end up using that in most of the applications that I've worked on, not necessarily using like local storage or anything, if that's what you mean, to persist across.
No. It's Apollo has a library to handle like local states too.
Oh, gotcha. Apollo link state. Yes. That one. I have poked around with it a little bit, but I've actually found that I haven't needed it. I haven't had a global local state that I wanted to model into the applications that I've been working on. Mostly I've been able to get by with a little bit of just React set state historically, or now hooks and use state is a way to provide that, or a reducer as well in the hooks world, or it's state that's coming from the server. So it's nice that it's there, and I'm excited that there is, like, if we have enough of that larger scale state, I have a graph. I have the same way to interact with my data no matter where it lives. I like that story, but I've yet to actually have anything force me into that. So I've been able to get by with the simpler options.
Yeah, one thing that I've seen a lot of historically is we talk about like shifting complexity, how GraphQL itself is significantly more complex on the server than like a REST endpoint would be, right? Especially the story around caching. But you're saving clients a lot of like significant complexity. So if you pretty much look at any like sufficiently complex REST endpoint, generally there's an SDK to go along with that to make interacting with that endpoint easier for your clients, right? So there'll be like SDKs implemented in all these different languages, which does the same sort of thing as like, oh, well, you don't need to know how to do this sequence of like REST calls to make this one thing happen. So here's this like client that we've generated that will, take care of a lot of this stuff for you. So it ends up like we push a lot of complexity down to the clients to kind of make up for this, kind of lack of, guarantees about how all this stuff works, or lack of documentation or whatever, just like make it simpler. So ultimately we're getting to the point where we can have like thinner and thinner clients. And, like you're saying, Chris, you see like much less of a need to use things like Redux, because it's like, well, now I don't have to do all these kind of transactional things to make this stuff happen. It's just like I got this really kind of simple view to like be able to fetch basically only the data that I need for this one thing. And it makes a per component like interaction to sort of any like product level interface super, super simple. And I think if you're on a product team, and especially if you have multiple clients, it's a really compelling story around that. It's like, it's not that you're never going to have any complexity, because you definitely will. You can't get away from like providing data to multiple clients without having complexity. It's just, that's going to be part of your life. But it's being able to iterate on products really quickly from the client's perspective is kind of what this power and freedom GraphQL provides.
So one question to y'all GraphQL experts: what are the bad parts? Like everything's a trade-off, right? So what have been the bad parts you've come across?
So fair comment that nothing is without its trade-offs. GraphQL is sufficiently younger that there are less patterns out there, that we're seeing a little bit less clarity around how to do certain things. Granted, I think the standard, and the fact that it has a standard and that the implementations are essentially the same across every server implementation, is fantastic. And so there are a number of questions that have just been sufficiently answered. But a couple of things that do stand out are error handling is still very much, I would say, being figured out. I think the community is starting to come together around the idea of actually pushing client-facing errors into the type system. So historically, the way errors work in GraphQL is when we get a response from the GraphQL endpoint, we'll get back an object which has data as a key, and then from that, underneath that key will be all of the data that we requested in the shape that we requested it. But if there were any errors, parsing the query or getting the data or access control or anything like that, there's an adjacent errors key. And then the value for the errors portion of the response is, I want to say it's an array of objects where the objects have a key that is, or they have a message and then they have a key that is type or something like that. But it's very, very loosely structured, especially in contrast to the strongly typed data that we have coming through the data key. So it's sort of surprising how loose that is. And historically, I've seen folks push errors into that area. But again, then you're falling out of the type system or the strong types that we can guarantee. And you're also losing that clarity around what are all the possible responses I could get for this mutation. It can either return me, yep, that went well, sorry, you have to try again, or no, we had some other unrelated error. And it's less clear, the error case, but ideally, and this is a conversation that's starting to happen, what if we could model that in the type system? Particularly through what's called union types. So this mutation returns, actually to give a specific example, I worked with a client where we needed to update addresses. We're sending a string of data describing an address up. We hit the GraphQL mutation and it's either going to successfully update the address because everything went well, or it's going to say via geocoding that it actually resolved to multiple addresses. Can you please pick the correct one? Or it's going to say, sorry, we weren't able to find that address. And so we have these three distinct cases, two of which would sort of be considered errors, maybe. We weren't able to update the address, so in a way that's an error. GraphQL shines in this example because we are able to fully model that within the type system and say this mutation returns one of these three types. And then on the client side, we can say, okay, we know about the three types. We will make sure that we're handling all three, and we understand the different data that we're going to get in each of those possible cases. So the more that we can do that with errors as well, I think that's good. But that is definitely still something that's in flux. I think the other complexity is around some performance things on the back end. GraphQL makes it very easy to request a ton of related data. I often joke and call it N+1s as a service because it essentially is. It's also relatively easy, and there are developing patterns around how to handle that, but they are slightly different than, say, like doing a database join, which is historically the way that we would solve these sort of things. So I think there are some edges that are a little rough, but overall for me, the experience has been very positive.
Yeah, these two things are the things that have been like that burn me from time to time here. We use GraphQL. First of all, back when when you're dealing like with really with a page, let's say like a product page in Amazon, right? You're like fetching a bunch of data to render that page. Some parts of that data are more critical than others. Have different SLAs, will have like a quicker answer. Other parts, not only they will not be like fast requests, they are also not important for the flow. So like those APIs they do not need to be as robust. They will error more than the other ones. So managing this kind of thing, like in the crazy REST world, things were like atomic enough that at least that was handled straightforward, right? So like it's like, oh, I can separate this request from the other requests. I need to retry these ones. I don't need to retry those other ones. And the error handling, as I said, like the lack of a standard. If I am requesting a list of users, what if like 2 or 3 users fail on that request? Like how do I communicate this with the client, and what's the way that I deal with that? So yeah, you're right. Like these are the two parts that are kind of solved in the REST world. The REST world, you have like the HTTP codes and stuff that tell you a lot. It's pretty standard the way you will send a message together with that.
I will say, with regard to the first bit that you were talking about there, of we have different aspects of the page that have different levels of importance or different performance characteristics. I'll admit that I haven't actually played around with this aspect as much, but GraphQL does have fundamental support in the query language for something called directives, which are the ability to annotate your query and say, okay, I want the user, and for the user, I want their name and their email, and then I want all the events that they're going to. And then for that, you're asking for whatever, the date and something else about the events. But you know that the events are going to be painted lower down on the screen. They're of lower importance than the actual user data. So you can use the directive @defer. And that tells the server, first, get me everything that is primary. And then after that, when you're ready, please send down those other things. Or there's also a stream directive, which says, send me down all this information, but you stream down the like count as it's coming in or something like that. That's actually, I'm sort of conflating subscriptions, which are a different thing. But streaming says, I know that this is like the reviews, the list of reviews at the bottom of a page. There's going to be a bunch of them. And I know you have to hit a backend service to do that. Ideally, your client doesn't know that much about these sort of things, but it's an imperfect world. And obviously we have some knowledge. But from performance characteristics on the front end, we as front end developers can now make the decision and express through our queries using this declarative language of, defer this and stream this and give me this when you're able. And I love that it actually does have some really nice answers around that and the ability to change that on the fly as well. Like if we were in a REST world and there was data that had been inlined into a given endpoint, so this is the user endpoint, but for users, we're also going to return them the most popular repository that they have, say on GitHub. That's built in and I can't opt out of that. It's actually true of the repository endpoint. Every repository inlines the owner, and there's no way to get out of that. You are getting that information for every single repository. So in the talk that I gave, the base query that I do to demonstrate the REST side is asking for all of the repos for the current user, and every single one of them contains the redundant portion about the owner of that repo, which is the current user. So it's a perfect example of where, in some cases, we have to make compromises on the REST side that we ideally have a better language to support on the GraphQL side.
Nice. That's good to know.
Yeah, I would, to kind of dig into that a little bit more too, performance is definitely one of the hardest things that I see about GraphQL. And generally, it's the waterfall of latency. Like you could have GraphQL that's consuming multiple services and figuring out like where down this waterfall is like these actual services like delaying my queries. So we've seen like having visibility into insights of like what's actually slowing down a query can be pretty difficult. Now, Apollo has great like tooling that, as a company who sells like GraphQL services, they monetize a monitoring service that like helps you dig into like all your downstream consumers or whatever, and like gives you timing data for that. But generally, if you're not rolling with their premium service or you're doing something else, that can be kind of a hard thing to do. So like we're using Datadog, and we have to have like special headers and all of our responses to be able to have a distributed trace to see all the way down to like, from our GraphQL endpoint to our services through, to our like database is like, what is slowing down this query? And that takes engineering effort, and it's non-trivial. So, hopefully if you've got people with like expertise on those systems, they're already used to kind of doing that sort of thing anyway. I mean, it's not like this is a problem that REST wouldn't have. Mm-hmm. It's just hopefully like a smaller problem.
Or at least a consolidated problem. Yeah. That's a lot of my thinking around this is we will have complexity. We have hard problems to solve in building large-scale applications and platforms. And I love that with GraphQL, we can consolidate some of that. And one of the interesting things that I've seen in Facebook's trajectory over time is initially they had the adage, move fast and break things. And at some point, they modified that to a small degree, which was move fast and break things, but never the platform. And so the platform is the central core engineering pieces, which GraphQL being the heart of and serving so many different applications in their world, that is part of their consideration. I don't actually know that is fully part of that quote, but I'm going to now adopt it and say definitively in my world, that's the way I like to think of things. And so within organizations that are getting to a certain size, I actually really love the idea of GraphQL being this sort of choke point. And it allows for the simplicity on the client side that we've been talking about throughout the episode, but it also sort of shields from the complexity of SOA, which is more and more the pattern that folks are leaning towards as their applications and their platforms grow. That's a lot of complexity. And if I can hide that, and if I can actually stitch it together and provide a unified view of the platform data that we have, that's the dream. There's actually a specific talk by Nick Schrock, one of the creators of GraphQL, about how GraphQL is sort of a return to the monolith, a return to let's take our SOA and stitch it back together and make it into sort of a sneaky monolith again, because developers and humans think about the world in that way. When I think of Airbnb, I think of it as one cohesive thing. It turns out it is not. It is many, many small things that they are stitching together to make that experience that I, as a consumer, want to think of as a cohesive singular object. And so if we can do that with something like GraphQL, I think that's a fantastic way to at least consolidate some of that complexity that is inherent to these larger scale applications.
It's interesting. I mean, yeah, a lot of it just comes down to where do I get my data, and coming back around to that idea of GraphQL, having it all in one place means that you can remove some of the complexity from the monolith. And if it's all, again, all your data is mostly consolidated there. I like some of the ideas there anyway. I don't know if I'm coming to anything really clear.
Well, to be clear, we don't need to GraphQL doesn't require a monolith. It just
Right.
allows us to take a bunch of potentially disparate services and stitch them together such that our client applications can largely interact as if there's a monolith.
Right. That makes sense. One thing that I've run into that's also a trade-off for GraphQL, and this is mostly coming from my Ruby on Rails background, is that REST is sort of built in, right? You generate code, you generate a REST API. And I haven't done it for probably a year, but the last time I tried to set up a GraphQL, it just turned out to be a ton of work on the back end. And I think we've kind of nodded to that and said, yeah, that's kind of a thing. You move a lot of the complexity to the back end. But I'm wondering, is that getting better? Does it depend on the ecosystem? And yeah, where are the trade-offs there if you're working on sort of a full stack setup?
It's interesting the way that you describe that, because my experiences have been almost the opposite. I have really enjoyed building GraphQL servers, even in Rails. The reason that I say that is, like, when I think about building a REST API, there's a lot of decisions that I have to make. Like, is this going to be a separate endpoint? Is this going to be nested? How are we serializing the JSON? Is it active model serializers? Are we using Rabble in this case? How many different versions of the payload do we have? Which data do we include or not include? And none of those questions serve the front end. None of those questions serve the customers, the ultimate end user of the application. Mm-hmm. And I cannot think of the time that I've had what I would want to think of as like the Rails up the middle. That was easy. All the boring stuff was figured out, and I just got to say API, please, and then my data was in an API. Or if it was, I think it would be too magical, because then, in the same way within Rails, Active Record just makes anything that's in my database available as a method on my classes. Like, that actually may be too much.
Yeah, I wind up turning a lot of that off.
Right. So
that's true. That is the decision that I wind up having to make.
So I actually love that GraphQL gives us this purposeful moment in time to say exactly what and in what shape are we going to expose the data of our system. I almost feel like it was a missing aspect of architectural design within systems. Now that I'm having the conversation, I'm like, does a user have one profile or is it two? From the front end's perspective, I know how it's modeled in our database, but how do we want to, what words would we use when we're talking to the business team about this? And GraphQL allows for a place where we can actually have that conversation and encode it and enforce it with the schema. Then from there, it's actually, I find it's pretty straightforward wiring up. I will say Rails is, unfortunately, Ruby and Rails generally, I think they're a little bit more complicated in that there's a little bit of a mismatch in, we don't have types, we don't have functions as first-class objects, things like that. So the code that you write to build a GraphQL server in Rails looks weird. It doesn't look like idiomatic Ruby or Rails.
I think that's where I kept getting hung up, right? Is that it's like, okay, this looks, it doesn't feel natural the way that some of the other stuff does.
But I will say there has been a lot of good effort in the GraphQL implementation in Ruby. That's moved in a lot of good directions. They've taken care of like camel casing and things like that, which is one of those things that I would like the platform to just handle for me. I don't want to have to think about that. And some niceties around using classes and being a little more idiomatic Ruby so that we can have code reuse and testing and all of the things that we would expect to work a little more closely to how we would expect them. That said, as you move into other languages like JavaScript is obviously the initial and the reference implementation, and it's very straightforward to do that. Scala has Sangria, which is one of the standouts that I've seen. It's one of the most featureful implementations of GraphQL, and that's a great example of where you can have types in your database that flow into your GraphQL layer, that flow out to your client, and then if you're using TypeScript or Flow or something like that, you get this consistent, strongly typed thing all the way across your platform, which is really interesting. But I've actually really enjoyed the process of building GraphQL APIs, and I feel like I'm fiddling with the right bits. The hard parts of building a GraphQL API, in my mind, of building the server-side implementation, are considering how to structure the data, those are the sort of things that I want to spend my day-to-day work on. I've got cycles for that. I don't want to have cycles for deciding active model serializers or Rabble or whichever of the others.
No, that makes sense. I'm going to have to try it again, see what's changed.
Yeah. So one other thing, I guess going back to that conversation of what's hard in GraphQL, I think caching is something that you can't not talk about. I know it's a minor, not minor. It is a performance thing, kind of under that same umbrella. But I find that so Facebook provides this tool called a data loader, or they introduce this concept called a data loader, right? So it's like as you request data from a specific resolver, then you can cache, that sort of request. That's still kind of a non-trivial story. It can be hard, figuring out how do I effectively cache this. And if you have an endpoint that's getting hit a lot, you have to deal with that. And in a REST world, you have HTTP caching, so you can offload a lot of traffic potentially to something else. You could theoretically have edge cache, something like Akamai that handles a lot of load for you. And, just when your data change, you update an e-tag header or something like that, right? And that can be the way that you can not have to worry about taking a lot of scale in your system, right? So if you are working on a product that maybe has millions of users, that'd be a concern, right? Because everything has to hit the GraphQL endpoint. So that's a lot of potential traffic there. So that's a challenge. With that said, I feel like GraphQL is easy to kind of scale from the perspective of having multiple parallel instances. So I don't feel like that's a huge problem, and you can definitely work through the individual resolver caching and stuff like that. But it's still something that your team's going to have to deal with.
My somewhat lazy answer, at least at the start, is with GraphQL, because you're able to boil down almost everything into a single request, the benefits of that in terms of latency and just making a single request often overshadow a lot of the other performance benefits. If I'm making 5 requests and they are strongly cached at the HTTP layer, but there's still 5 of them, then a single query, even if it's hitting the database and having to do all that work, is still going to be a performance win. And the simplicity is fantastic. That said, you are totally correct that we lose HTTP caching. Basically, almost as a rule, there are actually some workarounds and some things that you can do, but then, like you said, they take additional work. We have to sort of change the way that we would do GraphQL queries, possibly for the better. Rather than sending up the entire string of the query every time, there is a way to use what are called persisted queries. So you essentially hash that query string, and you send up just that hash. Facebook and other large organizations use this both as a performance and a security sort of thing. So they validate, this is a known query. We've approved this one. It has known performance characteristics. And then by virtue of only sending up that little bit of data that's just that hash, we can actually use HTTP gets again. And then from there, we can actually use the HTTP layer for caching. Granted, I've not worked on a system that actually does that, but I know that it's there. And in those sort of I'm on a very big system and I know that we're going to have a lot of public traffic that's hitting the same sort of queries, I would probably lean towards that because that's a simple way to push the caching story back out to HTTP, which, then you get however many layers of the browser is going to cache and the CDN is going to cache and everybody's going to cache that. But then there are additionally, like you said, some things on the back end. Data loader both is a pattern for handling some of the N+1 issues, but then also caching some of those requests. So it definitely is work, but ideally it's work that you get to do once-ish, and then you've built this platform that can hopefully grow. But yeah, trade-offs, they're always present.
Yep.
It's true of life too, right?
Indeed. How life models code or code models life. Yeah.
Yeah, very much so.
We talk about opportunity cost, and it's just that our browser measures it somewhat when we're talking about the code. So
what gets measured gets managed, as they say. So here we are.
All right. Well, is there anything else that we should dive on with this, or should we go ahead and do picks?
I feel like that was a good whirlwind tour.
Good deal.
Yeah.
Chris, if people want to find you online, where do they go? You can mention your podcast again, and then anywhere else that people see your stuff.
Sure. So I'm Chris Toomey on Twitter, and from there you can probably link out to anything else that I have. The one other main thing is the Bike Shed podcast, which is @_Bike Shed on Twitter, or bikeshed.tv. Bikeshed.fm if you want to find us on the internet and hear more of what I'm doing from week to week.
Good deal. This episode is brought to you by TripleByte. Applying to programming jobs sucks. You have to put the right keywords in your resume, you spend hours and hours on the phone screens and take-home projects, and that's assuming the company even responds to your application. Well, if you're a software engineer, TripleByte can help. They work with over 400 top tech companies, from big names like Dropbox and Adobe to exciting startups. You do one brief online interview with them, And if you do well, you go straight to final interviews with the company on their platform. It's like the Common App for software developers. TripleByte does not look at your resume or where you went to school. All they care about is if you can code. I've helped dozens of software developers with various credentials get jobs, and this looks like a terrific way for you to get in and get interviewed and get a job without a lot of the hassle and overhead. You can go check them out at triplebyte.com/react. That's triplebyte.com, byte as in 8 bits. As a special offer for listeners of this show, if you take a job through TripleByte, they'll offer you a $1,000 signing bonus. Well, let's do some picks. Justin, do you want to start us off with picks?
Yeah, absolutely. So I've got 2 picks today. One, we were talking about GraphQL errors earlier. So Artsy has a good blog post on how we handled GraphQL errors, and it was exactly kind of like what Chris was talking about. It's like actually encoding the errors into the schema. So definitely check that out if you're trying to figure out GraphQL errors. And the other thing is, so I've been working on revamping the release process for some of our JavaScript dependencies at Artsy. So we were using semantic UI semantic release. And it really we weren't using it how it's supposed to be used, like, an actual commit prefix for every commit that like describes what level of change it is or whatever. So we found this package by Intuit called Auto. It allows you to have per PR releases based on a label. So we'll have a label that's like version minor, version major, and then when that PR is merged, it automatically ships a release. And that tool has been amazing. So working with the Intuit team has been phenomenal. So I'd highly, highly recommend you checking it out. If you are working on a project where you need like easy GitHub releases, definitely check it out. And that's all.
Awesome. Lucas, what are your picks?
Yeah, so it's been a while. I've been working with Markdown to create presentations. And now I'm totally into, let me see the links here. I'm totally into the MDX deck library. You just create like one file. It's a MDX because it's Markdown that accepts React components. So it just makes things like so simple and fast to create presentations. I'm building one today to present in the Frontend Guild here at ZocDoc. And I found this morning a library to use with it that is really amazing. It's called the Code Surfer. So it's a library to help you present some code in a presentation. So if you have like a piece of code in a presentation, Code Surfer makes it so. First of all, it's like beautiful out of the box, and second, like you can create like next steps that like highlight these lines, highlight this range of lines, zoom in here, put this notes when it highlight this line. So it's really easy to create code-based presentations if you're showing code to people with this library. So yeah, this is my pick for today.
Nice. I'm going to jump in with a few picks. It's interesting doing picks. It just occurred to me because I did 3 shows yesterday and I'm doing 3 shows today, and I did 5 shows on Monday, and I'm trying not to pick the same thing across everything. So anyway. So I'm going to jump in here with a few picks that I have. And one of the things that I recently did is I recently revamped the way that we do scheduling at devchat.tv. And what's funny is that our hosts, I don't know if you guys noticed this at all, but the only thing that you would have seen different is that the ongoing reminder for React Roundup is gone unless we have an episode scheduled with a guest. And you only have 1 appointment in your schedule instead of 2 or 3 or 5. Or I think JavaScript Jabber had like 5 of them if you were a panelist. And so we fixed all that up. And so the tools I'm using for that, I'm just going to throw those out there. One of them is HubSpot. HubSpot's a CRM that allows you to do stuff, a lot of stuff. I'm using it to find and market to sponsors, but it has the calendar feature in there. So we moved off of Schedule Once since I'm paying for HubSpot, and we've moved everything over there. And boy, that made things a whole lot simpler. So yeah, if you're scheduling now, you're using a link through HubSpot. And yeah, everything else just kind of happens naturally. And by naturally, I mean through Zapier. So that's the other tool that I use. And Zapier connects to all kinds of things, including things like GitHub and stuff like that. So if you have any automation processes, Zapier's a good option to go look at. So what Zapier does is when a guest schedules the episode, it goes onto a calendar for the dev chat team. So it doesn't go on my calendar. It doesn't go on Michelle's calendar. It goes on the team calendar. And then the Zapier is looking for new appointments on the calendar. And when a new appointment pops up, it's looking specifically, in the case of React Roundup, for React Roundup podcast episodes. And it goes and prepares a Google Doc where we get all of our prep information from the guest. It adds that document's link to the calendar invite. So then the guests and the hosts have a link to where to show up, and they also have a link to where to go to prep. And then it invites all of the current co-hosts to the appointment, and it also invites Michelle, just so that she knows that it got scheduled, and for everybody else it shows up on their calendar, so they get a calendar invite on every one of them. And what's nice there is that, let's say that somebody couldn't show up, they could just mark it as, I'm not going to be there that week. So in a few weeks, I guess it's about a month, I'm going to be at Podfest in Orlando, and so I'll mark that one for me as I'm not able to attend. And and then everybody else can see who's going to be there and who's not going to be there. The other thing is that I'm working on is working things out now so that it'll start telling us how far out we have episodes scheduled. And my goal is to have us scheduled out at least 10 weeks ish, so it's 2 months, and that way we know what's coming up. So if people want to go prepare ahead, they can. It also allows us to give information to the sponsors and things like that. And so I'm working a lot of these systems in now to start getting more numbers and more critical information about what we're doing. And so anyway, it's been kind of fun to set all that up. But that said, I'm using those two things, and then I'm using a Google spreadsheet to keep track of the numbers that I just mentioned. So how far ahead are we on recording, on scheduling, on editing, on show notes, and anyway, just keeping track of all that stuff so that we know if we're close, where we need to focus our attention, and all that good stuff. So anyway, so I guess my picks are HubSpot, Zapier, and Google Docs, or Google Drive, I think is what they call it now. So anyway, Chris, what are your picks?
That was a very elaborate summary of all of the things that go into planning your podcast. Mine, I don't have any of that. I should look into some of that. But yes, so for me, I have a few picks that I want to run through. The first is a service called Tell Me When It Closes. So this is something that we built here at ThoughtBot a number of years back during a holiday hackathon. But its job is, often there are issues or pull requests on GitHub that you're very interested in, but because of being part of a large open source project, like say a recent RFC for hooks in the React world, there's going to be a lot of conversation on there, a lot of chatter. I don't necessarily want to subscribe to that issue on GitHub because then I'm going to get an email for every single comment. Mm-hmm. I'm just interested in what happens when it closes. Did they decide to do it? Did they decide not to do it? What version are they going to build it into? So with Tell Me When It Closes, you give it the URL of the GitHub issue or pull request, and it will watch that on your behalf. And when it closes or is merged or whatever the relevant state is, it will send you one email with a link back to that issue saying, hey, that closed. This is great for bugs in smaller open source projects or those sort of discussions and bigger things like Rails and React and places that there's a lot of noise and that you're very interested in the outcome, but not necessarily involved in the conversation. So again, that was Tell Me When It Closes, which is tellmewhenitcloses.com. I was very excited we could get that URL for it.
Awesome.
Next is a project called QuickLink, which comes from the Google Chrome Labs team. So if anyone out there is familiar with Gatsby, which is the static site generator for React, it has some wonderful performance characteristics just sort of out of the box. One of the ways that it does that is by dynamically prefetching links. So as anyone's looking at a web page that was created via Gatsby, behind the scenes, the JavaScript is running and actually seeing what links are visible on the page and prefetching those behind the scenes such that when you click on that link, it's almost instantaneous because you've basically already preloaded and cached that page. So I was super interested in that performance characteristic and the way that worked, but I didn't necessarily want to rewrite my entire blog in Gatsby. It's the sort of thing that I've done too many times in the past, and I don't actually write enough blog posts to make that a useful bit of my time. But thankfully, the Google Chrome Labs team has basically pulled out just that bit of functionality and released it as this project called QuickLink. So it's fantastic. It looks at just the links that are visible on the page. As you're scrolling, it's watching and seeing that. So it's going to be reasonable with bandwidth usage. And it even has a setting for if users want to opt out of aggressive use of bandwidth, there is a setting in the browser apparently that you can use, and it will respect that. So in all ways, it seems like it was designed incredibly well. It's a great example of progressive enhancement, but it just makes things instant on your sort of site. And it's a quick, like, drop it on your page and it works. So that is a fantastic project. And lastly is the service Upcase that I mentioned a little bit earlier on. So Upcase is Thoughtbot's online learning platform, which for 5-ish years we ran that as a business. We would sell that to folks, but a few months back, actually back in October, we decided to open it up and make it entirely free. So this is many, many hours of tutorials and workshops and in-depth discussions with Thoughtbotters. There's a number of hours of me talking about things like Git and Vim and Tmux if you're more interested in workflow. We have a lot of things about testing, Ruby on Rails, and then just general conversations about how to think about being a developer. So I was thrilled that we were able to actually open that up to the world last year. And so now it is entirely free. Anyone can come and watch any of the videos, explore some of the coding exercises. We have flashcards. There's a forum. There's a whole bunch of fun stuff on there. But yeah, it's free. So everybody should check it out. And that's at thoughtbot.com/upcase.
Awesome.
Very cool. Well, thanks for coming, Chris, and talking through this with us. That's exciting.
Thanks for having me.
And yeah, we'll also encourage people, since this is a podcast, to go check out the podcast that you're on, Bike Shed Podcast.
Sounds great.
Yeah. I love talking about this stuff. I love seeing where we can make things better. So yeah, this is terrific.
Well, thank you for having me.
All right. We will end it right here, and we'll catch everybody next week.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.